Okay, so let's start. I want to start by giving a quick review of the slides that Janaf shared to what are the parts that we should be focusing on this lesson. So this is his PDF, is pinned in the Slack room. So something that we need to be mindful is that the code has changed, not significantly, but mostly things have been added. Some of them have changed names, and we need to make sure what are we following. So he makes us the point, for example, for this one, session 2 can be divided in 3 sections. The first one was finishing the pets notebook, which we did last time with the tutorial pets. We look at the transform list, data loaders, data sets, pipelines, and what's the difference between those. So we're going to start today with just the data transformation. Should be a very short lesson, and we're going to leave the next part to be the data core for the last part of session 2. Okay. Let me start by saying that I installed FastAI 2 on first ingredient in Paperspace, but for some reason it wasn't working this version, so I just went to Colab. If anybody has questions on how to make it run on Colabs, please do ask, and I have a couple of questions in case anybody else has experience of what I was able to do in Colab and what is not. Okay, so we're gonna start by looking at the, just importing the sections. In this particular case for Colab, the only thing that I did, I had to install everything in the library. So I actually downloaded FastAI and installed it directly here to make this notebook work. If anybody has any other ways of doing it, let me know. Okay, so what we're going to cover today is gonna be just this part of when we're looking at the data sets, how do we get the documents or the images or any kind of files, maybe some tabular data, how do we read it into the data structure, how then we split it into train and validation, different ways of doing it. Sometimes it's just random splitter is the one that we have used the most, but sometimes that is not good enough because, for example, for time series, you don't want to have a random split, you want to have a time split, for example, or maybe you just already have some predetermination that this is my data set. So we're gonna see different ways of doing the split and how to label. Again, how do we get the label? The label could come from the file name, in the case of images, the example that we have seen, and any other ways of doing it. How do we create a simple class categorize, and then the transform categorize that we saw, we're gonna use again to get the Y in our models. In the cases that we have multiple labels, in a simple example with MNIST. Okay. So when we're starting here, I just want to say that the most basic thing that we need to be able to do is get access to the data. And oh, this is the part that if anybody else has a way of how to do it into Colab, I'm able to show from the document where should be the source. But when I get the source, we can see that I actually have the correct link, but I cannot open this. It doesn't work for me on Colab. If you got the source link to work on Colab, please do let us know how to do that. But in here, we can still show where the documentation, and if you know where it is in the documentation, then you can just go into FastAI and follow out there in what it should be. You know? For example, in here, if you know something that should be in data, for example, data transform, you can go and find it in here, right? But obviously, the part that you want to be able to get to work is to get it directly when you do that. Here, just documentation and get the link. Okay, so in this example, what we did was just download the data. Yeah.
So I think if you could do 2 question marks, that's when the doc shows up. Is that what you're asking?
No, I did do that. So for example, if we do that, we get, sorry, I should be the other way. You get the explanation. So it's true. Yeah. In the right side, you're gonna get this explanation, this window over here. Yeah, it's good. You can look at all the data. The part that is broken in here, I don't love this part because it's taking part of my screen. If you click here and if you do it not in Colab, but if you do it in your own machine and you click on it, it just brings you directly to, you see, to the GitHub. To the part of the GitHub that. And that's really nice because you can just go directly to the code, right? If not, I totally agree. What we should do is just read it here on the right side. It's just not the same. It's a lot easier if you go directly to the GitHub. That's what I say. We can still show it. You get the link in here and then you know exactly, for example, this is data external API. Okay, so then you can go to GitHub. This is the normal GitHub. and find it. But then you're doing the work of going to data, external API,
Okay.
and you have to control F over here and find whatever you were doing in here.
Sure.
That was just that point. I really like how Jeremy makes a lot of effort into this literal programming and how to make everything self-documented, and you can go and look it up and find it, right? So he put a lot of effort into this. So yeah, let's try to get it to work. Not right now. Okay, so another thing that was interesting, remember, it's important to say that these are not tutorial notebooks. What he's doing is actually creating the code. So anything cell that has the export is the code that we're gonna export and we're gonna create it, and where it's gonna go and live. Let me see if I can find it here. It's gonna go and leave. What is it? Yeah, actually it's true. It gets just this part of here, right? Notice that this is auto-generated. This is not code that he wrote directly. This was generated with this file. So notice how the notebook is this. This is the notebook that has the code, and this is the file that gets auto-generated. And then the other part I consider that is very important is that he actually enumerates which are the methods and classes that should be included in here when you import all. So that's why he said you should feel very confident when you're doing a module in FastAI. You can import everything in the module. You don't have to go and only import the file getter because I don't want to have some name collisions. Because he's very explicit on what it needs to be imported only, instead of importing everything that is available in the node. The only part that he said was relevant on this part is in get file. They said they put a lot of effort in how to read these image files in a manner that was efficient, and they were very happy with the results of OSWalk. This allows you, according to him, to read even 1 million files in a matter of 8 seconds. Again, we're not actually opening the images in this case. In this case, all you're doing is going to the directory and immediately just doing a directory list and getting the 1.5 million of name of the files. I'm sorry, I'm not seeing if I have anything on the chat. Please do talk because I think I lost my chat. 1 second. Yeah, I have some in the chat. Let me see. 1 second. I did install MDev. It didn't actually do it. It's just a setup in Colab. If you do it in your machine, if you do it directly on the Mac, it will work. So the only part that I couldn't get it to work was in Colab. Yeah, on your own personal, that will get it to work. Thank you. Okay, so in here, just important to know, like he said, this is a function get file, and we're going to export it. That's going to be part of our core notebook. And notice how we are also exporting this part with the underscore, but this is considered a private, sorry, someone is typing. This is considered a private function because it has an underscore. So this is smart enough to determine that anything that is with an underscore, I'm not going to import it. If we actually come in here, we see that only we're going to get files and not the underscore. So this is to protect our private methods. So this is also how we make sure that everything is only what we want to get out. Okay. We can still explain this one, right? What is it? And it will still show it in here on the right side. What is it doing? As we can see, this is really straightforward. All that he's doing, we can see it in the internal one. You receive a path, it's a path object, and what is the files that you're going to do, and you're going to make sure that you only bring the extensions that are relevant. So in the examples that are here, the only part that I consider was interesting was this certify, that basically you're just forcing it. We can see over here, you're just forcing it to be an object of that type. That was new to me. But in here, all you're doing is enumerate OSWalk. I believe I put it somewhere where, yeah, in here. OSWalk, I just said that it was a super efficient way of traversing all this path. And just the part that is interesting is that you have at least 10 different types of getting the contents of a directory. This is the one that they choose to use because it's the one that proved the most efficient. If there are no any questions in here, we can just go an example. For example, in here, they're just getting the files on this particular path. Remember, this was an example of the MNIST data, which just means it's going to be some images of the digit tree. We're going to get all the images because I'm asking for the extension PNG. In this case, because it's a flat directory, I don't need to be recursive. As we mentioned, what we're going to receive is this object L, which we know is going to be one of the objects that basic basic objects that they define. It's just a list, but a little bit more amicable to what Jeremy wanted to do. It has 346 files in this case, and this is how one particular object looks like. It's just an URL, and we know that it's not a string, but we know that it's a positive path. Again, this is just for efficiency. What he said that is important, that how it works. In the first line, I'm just getting all the files in the directory 3 and all the files in the directory 7. And that should be equal, or it should contain the same number of files that if I get everything that contains at the root level. So this is just doing it 2 different ways. I can get through the specific directory of the class, or if I even do it at the root level, at least it should match on the number of files. There wasn't anything particular interesting there, except we know how many files we want, and we want to make sure that we get the number of files that were there. The other part that was interesting is if we have a generic file, get file, and then what we start creating partial functions, anything that ends on ER, like file getter, it's gonna be a function, it's not a class, and it's gonna go and get specific things. In this case, just gonna get files that start in that specific folder of that specific extension. So we see an example of, well, what if I just wanna get my PNG files? Then I can just do an instantiation of that particular function, partial function. All you have to specify is that PNG. And in here we can see that how it works, right? It will, once I have the instantiation of the function, I can just get my 700 files, and this is how they look. So if I'm gonna be using reading files that I just want to be specifying the extension, I should get my file getter for anything that is frequently for you that you're going to have. For example, images, we know that we're going to be working a lot of images. So we're going to have not only our get image files, but we're also going to go our image getter. The only thing that is different in here is that in image getter, we make sure that they tell them only get items that are of the type that it can be a valid image. For this one they used in this class, that if we can see here, well, it just tells us all the different extensions that are valid images. So this is how we make a specific image getter from here. Before, yeah, so the image file will just get us the files when we know that it's only images. And in here we say that yes, we want to go with recursive. For example, in many of the data sets, sometimes we use subdirectory structures to determine classes. So we want to make that is recursive. And here I was just making sure that we know how to use one. So we declare, this is the partial function. This is how I'm going to create my instantiation of that function. And then I can send it a particular object and retrieve all my data.
Sorry, can I ask you a question? So image getter is to get the image recursively.
Yeah, so the difference is the other one, we have image files that you can define the folder. So this is one just because it's frequent. So let me see. Yeah, it's the same as file getter, but for image extension. So in this one in particular, you set up that is recurse true.
Okay, and what does it mean to have a recursive? Let's say we had an example up there, like where we have images in a folder 3 and a folder 7.
Yeah, so if it's recursive, that's what it means, right? If you are here and I say recursive equal true, then I'm gonna go and retrieve the files all the way to the bottom. But if I say recursive equals false, like in the MNIST example, so that means I'm just, or in the one in the top, we'll go see it right second. I just means I'm gonna retrieve from here. I'm not gonna go, so just from the parent folder without going in deep.
Okay, but we had one example. If you go up when we said T is equal to get files.
Yeah.
Down below.
Actually, we said recursive equals false.
So
yeah, because in this, notice that you didn't give it, for example, if I wanted to give it the path, right? If I only give it the path, then maybe I have to do recursive equal true because the files are not at this length. Let's see what the path looks, but it should be just it's up to the folder MNIST. This folder, if you look at the content of this folder, what it contains a subfolder called train. And inside the subfolder train, then we have another subfolder number 3 and another subfolder called 7. So if I'm just getting it, for example, if instead of this, I put this, let's just do that, that should fail because the files are not there. Let's see. You see? Because in this particular directory up to Emma's Tiny, there are no files that are there. There are no PNG files. Let's see if I do, okay, but try recurse equal true, which I'm telling it, go and look for anything at any levels. You see, it went, got them, and now we do find them.
Okay,
So
yeah, so what's the difference? So I still not got the idea. What's the difference between get files and get image getter? So because recursive is present in both the calls.
Yeah, so imagine this one, and if we go all the way down here, this one is the inner function. This is the core. This is the one that everybody else is going to call with different parameters depending on what you're trying to do. So then what you're doing is you're building partial functions on top of it for things that are very frequent and common. So for example, if you know that you're going to have directories in which you want it to be flat, like because I'm going to specify the path, then I'm going to put one that is going to be always recurse equals false, for example, which I believe, for example, getter, it says, let me see which one it does. It uses just the suffix and in folder, and it gives you some arguments. But I don't see the difference, what is exactly what the one is doing, but file, then images, for example, in here, image getter, we know that what it's doing in here is making sure that you're going to retrieve only the images files. Imagine that in a directory, for example, for some segmentations, in a folder, you have both the image files and then the annotations, like the JSONs. So you want to make sure that when you call it, you only call the image file. Well, then I can call just this part when I'm saying get the image files, because I'm already saying it for that, I'm only going to have the image extensions, right? So I'm going to make sure that I only call it when on files that I'm going to be able to open and show. So but if you notice at the end, it's still calling get image files, and get image files is still calling get files. So again, the core is the inner function, and then you're just building functions on top and specifying what things are going to be.
Okay, yeah, got it. Thank you.
Let me make sure we said where it was done. I might have deleted a sentence here when we were discussing. And then once it works, yeah, we got all the files that are there. The same way, and I didn't look into these details, you can do it for text files. Again, it's just specifying what am I looking for. So instead of calling it, again, I can just call directly this get file, right? This is actually the call that I'm doing. But instead, I can just wrap it up into this partial function when I'm calling text file, which can be more natural when you're writing. This is the part that we're trying to build top levels that I know I'm working with text. Instead of going directly and saying, oh, which are my extensions, I'm going to call my functions get text files. And you can play with this and make something that only the type of text files that I'm interested, not all possible things that I can read, right? I believe that's what I would say is the most important part for get. We just talk about the functions, we talk about the documentation, and just that they spent a lot of time. And I believe that's true. In my experience, for example, I work in Azure, and just reading from blobs, it really matters how you're reading your files. It can be a difference between minutes and hours. If you're reading 1 million files, you have the right function. I haven't actually done this in Python with the OSWAC because I was doing a different type of file, but it sounds like they spent a lot of time in it. Okay, so remember, this is just, once we're going to do example at the end where we do the data set, and where the data set is gonna be just the m tiny digits. But this is what am I going to do when I'm doing that at the example at the end. I'm going to read the files, I'm going to split it and train and valid, and I'm going to then use transformations for both my images and my labels, and then I'm going to show my batch. This is what we're trying to get today. So this is, I believe, what we have used so far, which is the random split. It is the basic one. All we have to do is the valid percentage. Make sure that you spend the seed, and notice that the seed, they're putting it at the torch level to make sure that it really goes in there because you can put seeds at different levels, Python seeds and other libraries, but this is the one that is being used. So when we are doing this random splitting, what is it doing? Okay, we can see it here. All we're doing is a random permutation. Imagine, and all you're doing is what is the length of the data set. Imagine we have a data set of 12 images. All I'm going to do is generate my list. So this is just generating the index order. And then this cat just tells me how many of those items should be used for my validation. In this case, I have 12, so I should only use 2. Since I'm only going to use 2, then I'm going to return you 2 data structures, which is just going to be a list of indexes. One is just going to be 5 and 7 because it only contains 2 items, and the other one is going to contain from 6, 9, 1, 3. So in this one, we just shuffle the data and dividing it into our valid and train. Here, there's another example, just to make sure that all the numbers work. Now, this was just random. We didn't ensure anything. So notice that for this particular function, it's just using the one from scikit-learn, the train, and split, because that allows us to do some stratification, right? If we want to make sure that our classes are equally distributed, mostly when distributed as they are represented in the data set, particularly when we have unbalanced data set, we have 20 dogs and only 10 cats. I want to make sure that I get that same kind of proportion between my training and my validation, and not that I sent all my cats to the validation and then I was never able to train on cats. If you want to get more details, again, this is using it directly from scikit-learn. What matters is that in Stratify, you're using the label that you're sending it to make sure that that's the one. And then the proportions, again, if for example, this gender and the class was 30-70, then your proportions in your training set and in your validation set should be kept at 30-70, which is what he shows us over here. So we create a list, we create some labels. The list has 30 items, and then we put the first 20 to 0 and then 10 to 1, just to say that it's not balanced, and we declare 20% validation. Notice that what it means is, okay, what is my source? My source was just a number from 0 to 30. My labels, the first 20 were zeros and then were ones. And when we split it in this way, we can see that in here I'm just printing first what are my index for my train, then for my validation. And what matters in here is that the validation contains 6 elements. And if we count how many elements are below 20, which is how many elements are of class 0, we can see that it's 4, which is good because we're keeping the proportion 2 to 1. So 1/3 of my elements in the validation are going to be zeros, and 2/3 are going to be zeros, and only 1/3 is going to be 1. So we're keeping the stratification to keep the same proportions of the classes. And then he just go to, this is what you're trying to get with all these type of splitters is how many different ways are frequent for us to have specified the data set, and that we want to, in this case, how do we want to split it, right? Usually it's random. Sometimes we have a specific interest. So if you already have, let's say, a CSV file that tells you whether or not they're going to be using the validation with a flag, then you're going to have an index split that it allows you to read the specifications of which items are going to go to the training, which items are going to go to the validation. But as you can see, this from the Python perspective, all of this is very basic. All I'm doing is making sure I have enough methods that are relevant to how the data sets are going to be.
Sorry, one quick comment. He introduces also this function range of, which isn't a Python function. He actually defines it in his core, which it turns out actually gives you the range. So if you type, range of, sorry, 1F. So it returns the indices, making it easier.
Oh, because they're doing it for his collection, or what is the difference?
Typically, range will just give you the, so as you can see, it does the list of the range of the length of any element you provide. So if you say, for example, a list of 30 items, it'll give you a list which will be a index into the list of indices into the 30 items rather than the 30 items themselves. So that helps you keep it to indices when you're splitting by index and so on. So it's a custom function, and the reason I call out attention to it is Jeremy has a habit of introducing a huge number of helpful custom functions. So if you don't keep an eye out for that, you'll be confused and think they exist in Python, but they don't.
And then try to use them from somewhere else.
Right, and it won't. But so range off is an example of that. It doesn't exist in Python, but it's very useful in a lot of this kind of work, and it's a custom function that he defines.
Sorry, could you explain again what is the difference? What is exactly? I couldn't get it, and I'm not able to create a cell that gives me the result, and I cannot get this done.
Yeah. So if you just did so let's say X is an item with 30 items, or a list with 30 items, 30 parts, let's say, and range of X.
Yeah, like this part.
Yeah, in the case of range itself, range of doesn't help much because range will give you the 30, right?
Yeah.
So that's not a very.
It's gonna just give you the
Exactly, and now it converts it to a length and then makes it a list. So now you'll get actual numbers 0 through 30.
So it does this part that we were doing over here.
Exactly.
Okay. So it does all of that at once.
Yes.
Oh, okay. And that's what I get if so for example, can I do that? Can I just put 30 here?
No, because it's a length of X. So you don't have length of 30, right? So it has to be what you provide as X should have a length.
For example, source.
So range has a length, so that's why it works. But you have to provide it a tuple or a list which has exactly that will give you 7,000 whatever, or in this case 30.
And this was just 30, right? It's the 30 that we created over there. Okay, I got you. So in here you have an object, and range of will actually create the full array of it instead of what this was doing. It would just give us.
No, those are identical because range has a length and that gets converted, so the two are the same. But if it's not a range, if you just give it an X object, then that object has to have a length, because that's what, if you look at the code on the right.
Sorry, and in this case, source contains, because that's what we did, we just contain the numbers from 0 to 30. But let's say that source contain a list of files.
Correct.
Then what will range of that? It will give us the index, the list of the index of those files. Gotcha.
Yes.
I think we had, can we use anything from here that we had? Just to show that part. I don't think I have a list. Okay. Oh, that's interesting. Okay, so it gives you the indexed list, the list of all the indexes of the length of the object that you have.
Yes, and actually makes it into a list, explicit list.
Mm-hmm. Okay, perfect. Yeah, that totally, I missed that part. That was one of the Jeremy objects instead of one of our normal Python objects. And that's because we're only passing these indexes in here. What is he doing here with the public indexing?
This is a unique.
This is what we're passing it. This is how we're telling it which objects we want.
Yes, but actually the set diff 1D, what it does is it creates the
difference
difference between those two elements that you supply to it.
Got it. So in this one, it could be only, let's say, the indexes of 20 elements that I want in my validation. My object list, my list of files had 100 files. So this will be 100 indexes, of which one I'm going to then remove the 20 that I put in my validation. And that should be now my train.
Yep, you got it.
Got it. Okay, perfect. Thank you. So that's how we get the index, the inners of the index splitter. Thank you, Sina. The grandparent IDs is the one we have been using on the, so far I believe we're using the example of the digits because as we saw over here, that's the structure that we have of the path. Basically the path had, the data came on, this is the folder where the data is, then I have it in train, and then in here I have, no, actually this is just the parent, sorry. No, in this we're gonna use the parent for the tree. Sometimes this digit will be outside and that will be the grandparent. So if I have, if my label is in the direct folder on top of it, I'm gonna use the parent, and in this, if this were the class will be, then that will be my grandparent, which is what the next splitter is doing. I think the splitter is doing it. Oh, you're right, because we're in train validation, we're not in labels. So this is the, notice how this is trained. So if we go one below, which you have also the path for the validation, which should be called, we're probably gonna see how it's called, train. Let's see if I can find it, how it was called, train and test, got it, test. So the validation is either train or test. So as you can see, this is the parent, this is the grandparent. So you wanna get a folder to get all the files that belong to my train. I have to go to the grandparent and get all my folders that, get all my images that are hanging from this particular folder. And then from my other grandparent, which is called test, I'm gonna get my other data set. So these are, again, it has to do more the way that the data, it already has this format, so we're just doing the way of how we should do it. So this is the grandparent spirit, which is doing that, is getting the train and the valid for those. Yeah, we can see here train or valid in here, and we split on that, and that gets us to divide our data set. The other one that we have seen is if you actually have a function that you can run, usually the name, for example, for the pets, if whether it's a dog or a cat and you wanna run it is equal to dog because you wanna do a binary number, you just wanna get equal to 1 or 0, then you can have a function. I didn't look into more details of that. Srinath, do you have any other notes on the function splitter or the mask splitter?
Why is it like everything is in a partial function? Is it because that we want to actually like have it implemented as part of our like, you know, in our transforms? Is it, or? That's
a good question, right? So we're doing all these partial functions of ER. If you wanna, let me go all the way. If you wanna pick.
We touched on it in a previous lecture too. I think he just likes it, I believe, to be consistent so that eventually when you get to a transform and you define it and then you call the transform, it encodes as we discussed, and it's so whether you end up calling a splitter or a labeler or a get, file getter, item getter, he wants all of those calls in a way to be consistent. You just call it and then supply it, and that's what you do whether it's a transformer, that's what you do when it's a labeler, when it's a splitter.
Splitter.
Yeah.
But what is the difference in here? Notice in here, he didn't call, we did write an image getter, right? We did have a partial function called image getter. Nevertheless, he just get image files. And in here, he just used the grandparent. So in here, I find that inconsistent. I'm using the camel case ER function in here with the grandparent splitter. But in this case, I didn't choose the camel case ER function.
Right. No, when he's illustrating stuff, he has to use whatever is needed to illustrate things. But in general, in his code, he prefers to do it the way he does it, using functions which are pre-configured, and then you just like you showed on splitter, grandparent splitter, that's typically what he does. But obviously in these notebooks, when he's illustrating stuff, then
he might go back and forth.
Yeah.
Okay. Yeah, this is the part that he's saying, he's explaining why he does, or I mean, what he's trying to do here, that this camel case verbs ending in ER to create this function. So I believe that, yes, if you are creating something that is really on top of FastAI, you're not modifying at that point, this is the kind of functions that you want to build. And you want to build custom of these functions such that your notebooks do get to use this ER instead of having to build things and define more parameters inside the actual notebook. So it's kind of like just a cleaner understanding, I'm guessing. But yeah, noticing here we have the get image files and we have the image getter, and he did use get image file instead of image getter.
The other thing I think is like when we start building data blocks, your get-wise and your get-x's expect partials. Otherwise, if you can just directly pass in grand splitter, that we've already seen that in a data block, you can do splitter is equal to grandparent splitter. If you're using something like a get text file, then you'll have to explicitly clear the partial of it. So you'll have to do like partial of get text file and then pass in your parameters. So it's like a function convenience, I think. And I think in terms of following structure, if you look at your loss functions, for example, out of PyTorch, they follow the same structure. You do like n cross entropy loss, kind of define that, and then you use loss is equal to, and then you pass your like input and target. So it's kind of following both those things, I guess.
Okay. Let me see if I find anything else that was here. The splitter, splitter random.
One thing to point out is the important part also with mask splitter, for example, and in fact, it's because of the mask IDs function that he uses, mask to IDs, IDXs, that you can actually pass in binary values and have it split. So you can create excuse me, a list of true false from something, create that as a column and then split on it. So, and in fact, you can do the mask to IDs question mark, and it will give you that, you know, it can return a variety of different things.
That's the function mask to IDs?
Yes, the one he uses inside of index splitter, mask to IDXs, yeah.
So this is a flag.
Yeah, so it can convert a Boolean mask or an index list to a type of L. And while need not go into each of the lines of code, but bottom line, it says that if it's an instance of Boolean or NP Boolean, then return, and it returns the index for each of the enumerations of masks. So thereby it converts the Boolean values true, false, false, true that you have in the cell 47 down below into indices that then, that's why, because true is
Got it.
0, so it goes into the validation, and false means put it in train. So you can see that 0, 3, and 5 have gone to the test or validation set, and then the 1, 2, and 4 are in the training set. And that's because the mask splitter returns indices where according to which the splitter splits.
Okay. So I thought we had something else, but what is the difference between that and the function splitter? Function splitter is doing that, right?
Function splitter uses mask to IDXs under the hood.
Got it. Okay, so this is, again, when you have a custom data set for which you have defined from some other reasons what is your training and your validation. Maybe it's something that someone else gave it to you. This is the validation, and you just have them in a CSV with this flag. This is how you tell it to, this is how you're gonna read which one is training, which is validation. I've seen these when we're doing a little bit of, in my case was image object detection, and we have a sequence of images, and you don't want to get images that you are for your training that are very close to each other, because then you are data leaking. So you just have segments that are not related, and you can pick them sometimes based on the name, and you can do a function for that, or you can just have them pre-established in a CSV. These images go to training, these images go to validation.
Actually, if you go up, I don't know if it's a difference between the two functions, but true is usually used for validation and false is used for training. So if you kind of go up, I think index splitter is the one you were looking at.
Let me see when it was.
Right there, sorry, function splitter. So function splitter, if you look at the very first comment, it says
True for
split items by result, true for validation and false for training.
And because that one, Max.
I think that's what we use for like Camvid, because Camvid has an extra column saying is valid.
Which data set?
Camvid, a segmentation data set. I think
Oh, yes,
last
sorry,
time also
Camvid.
we were looking at Camvid Tiny.
Okay. And then I don't know if you have anything else at.
Column,
this is your
column
Panda.
splitter too, which is specific to the data frames. So that's very handy because you can supply columns as indices or columns as labels, as it shows.
And in our master splitter. So just the structure that was different. So in this we had nope, this is the mass splitter. I cannot see it this way. But in here you have, sorry, it's just this function of the list. So it's the index at each position. It already tells you whether it's 1 or 2, and in here it's just a data frame. Other than that, is doing exactly the same, right? So it's just what a structure matches. So you don't have to then convert it to something else. Like if you have a data frame, you don't have to then read this part, because if I have this data frame, I can just send this series that is going to be, if I put it in a list format to this part, right?
Yep. And that's an example of what, for example, Raquel was talking about. If in the Camvid, if it says is valid, is true or false, then if is valid is true, it will throw it in the validation set. And if it's false, it will put it in the training set. And you can do that right off of the data frame if it's in a data frame.
Yep. A lot of effort. If we notice in the actual original videos of the walkthroughs, a lot of these ones does not exist. So all of these are the new definitions. Then I don't know if you have anything about random subset splitter. We can see what it was. Oh, this is doing segments. So this is also one example. For example, if you are doing this, let's say, segmentation or object detection, and you have like a video, and then you want to get subsets to be the validation instead of getting random images throughout the video, again, because you don't want to be training on one image and then testing on the image right after. This is what you do. So you get your validation will be a different segment. Maybe if it's a drone video, then a different area that the drone was flying by, instead of just getting 2 images and then the next one I'm trying to validate, right? So this is what this subset is doing.
I think random subset splitter is if you have like a huge data set, but you just want to temporarily work on something very small, then you just pull out like 30% of that data set and work on. That's what I remember random subset splitter to be.
Yeah, so it just gets you, on a specific, right? But we can get that randomly. So imagine if I just have, let's say I have a data set of 1,000 images, and I'm doing something small, I want to work with 50. I can randomly get 50. It gets them from any place. Imagine that the images correspond to video. I can get them from anywhere, my random 50. Or in this case, I'm actually getting a sequence. I think that's the word. We're getting them one next to the other, if the numbers mean something, right? If the indexes mean something, maybe the indexes don't mean anything, in which case, yeah, they will be random. But if the indexes mean something, you're getting them one next to each other instead of just randomly get 50. So there are different ways of getting subsets, but this one makes to get them right next to each other. So you're getting different subsets in this case, from here to there, I think. But if it's not correct, please do let me know.
Yeah, no, I think you're right. It does seem to give the immediate neighbors because it goes in sequence. IDX is up to train length.
Imagine also time series, right? If you are, well, in theory, you should not look at the future, but if you want to train on one part and then test on a different segment, you want to use, because there is a time component, the validation to be related to itself, but not completely equal or very similar to the training data. So I think that's where this might be useful. Finally, the labeling, again, you just want to get the class name. This is about getting just strings from probably, again, the name of the data file. Parent label is the example that we were looking, just the folder in which that file was is going to be the name. It said that it's important that this is not a function because there's nothing to customize. It won't receive anything else. So it gives you the actual name. It actually returns the value. Not like the other ones that most of them return as a function, a partial function. But in this one, that's all that it's doing. In this case, for this example that we saw was just the name of the file. The parent folder is 3 because it's a class 3. And in this example, clearly the class is 3. And with example that, yeah, in our data set, we have 3s and 7. So that's very easy to understand. Then we have, this is the one that was covered in the last session, the regular expression. So you can extract it.
Excuse me. I don't know where the path object in the previous function, where did the parent attribute get defined? Or is it something that you expect?
It's here, right? So this is imagine that this is the name of the file, right? So this is your image. And then the parent is just the folder that it is.
Just forever, okay.
This is how the data set was structured, which is very common to have it divided. Imagine that you have a data set, you first divide it by a split, train, and test. And inside each split, you have subfolders for each one of the classes. So basically it's telling me, get my class name from the parent folder.
Okay.
And then sometimes the name could be inside the name of the file itself, not the folder. Like in the pets, all the pets were flat in a flat directory. I have all my images, let's say 700 images or 7,000. And then the file name contained what was the breed of the dog or cat. So we had to then extract that from the file name. It wasn't in a nice structure or a folder. So they can do that with a regular expression. So this is really custom, how is my data set? How do I extract my class from my particular file name, right? But this is how it will work.
Question, is this parent attribute, I forgot, is it part of generic Python or is it a pathlib attribute? I know name, I think, is a pathlib thing.
I think it is
yeah, Python. Parent is pathlib. Parent is pathlib. Yeah.
Parent is pathlib. Okay, thanks.
Yeah.
Name is pathlib too.
It gives the from FastAI dev to train/tray, the name calls tray.
Okay, thanks.
Sorry, and in the regs, we have the example. In this case, again, you can do one that when you are actually extracting it. So you notice they use the separation and then they're capturing here the digit because if we look at the name, it's true. Here it is, here's the string, right? This is the string that I'm looking at. And then they capture this separator, this other separator, and they say, if I have a digit, not a number, and followed by something else, a digit in between two separators, that's gonna be my class name. And so he has an example here. I have a separator, my digit, that is 1. There is no option of more or less, it has to be exactly 1. Another separator, and then I can define this regular expression function to extract the class name out of this particular data file. And yeah, we can see that it works. So there are many ways of getting the same output. And again, it has to do with how you structure your data, which one is easier or more intuitive for you to use on these cases.
So a question for you. Why do you think he's gone and defined a class regex labeler? Why didn't he just use the regular expression module and go from there?
Remember, it's what we were saying before. He wants to get these partial functions, which he called camel case. They're going to be a capital R, capital L, and they're going to end on ER. So when you see these kind of functions or these namings that ends on ER and is camel case, that just means it's a function that is wrapping up something that, yes, you could write it in your code directly. So again, what it's doing is not that difficult. You can do your match pattern just using the library regular expression. But in this way, it's going to be like more modular. You're going to be using this kind of functionality along lot of time. So you want to write it, and then every time you just need to write what is the particular regular expression. So if you have a behavior that is consistent and is frequent, you want to write a camel case ER partial function. That's the way I see it.
Yeah, no, and also as Raquel explained, right, it's consistent with the usage that you see in PyTorch when you operate on this kind of data, because I think he used an excellent example of the loss function. So typically when you want to change a loss function, you define it and then you say, loss func when you're using FastAI library equals, and then you can give it your own loss function call. So you can, for example, say my loss function and then the brackets, and that becomes the loss function instead of the loss function that's used by default by FastAI. Same thing for transforms. You can define a transform and then of your own, and then call it, and then use that elsewhere in your code. So it's and he's sticking with that type of consistency so that how you don't have to remember or something different. It's the same way you do everything. So grandparent splitter, you define it and then you pass in the parameters. So in this case, you have already defined regex labeler, so everything is set up and you just give it the parameters that you need to split. So for example, as she was just explaining, you just give it that particular splitting function, and capture group is just the single digit between the prior and the follow-up paths. And therefore you end up capturing just the 3 or the 7. So you don't have to worry about doing the setup of regex labeler. That's done for you with the camel case call to regex with the camel case definition of regex labeler, and then you use it elsewhere to just pass in the parameter you need for it to function.
Yeah.
Yeah.
Okay, thank you.
I just noticed something. I don't know, that FR that is before the regex function. What does that mean? Is it? I know normally it's supposed to be R. Why is it FR? Is it because it's a function?
Yeah, that is, I looked at it too. That's an interesting point you bring up. Thanks for highlighting it. It's just an F string with a real string appended to it. So typically you do R before a string for the real string, right? And in this case, it's a combination of F string and R. So I had to look into it as well. But basically, an F string is just F quote and then the string. In this case, it's F, then typically you do the R string for any regular expression to say it's real. So don't, if I recall, don't accept the...
I think it's for the slashes, isn't it? So you don't...
Because you're using this library and you're saying that bring the separator that corresponds to this particular OAS.
No, it's the real string. So whenever you do, for example, a regex, you provide it R something, and R, if you do a Google search, you'll find is because you don't want it to interpret special.
I think it's raw string.
Raw string. That's the word that I was looking for. It's not real. It's raw string. So here it's just combining the F string with the raw string. That's what he's doing. Yeah, I didn't know that combination could be done, but that's what FR quote does. It's an F string combined with a raw string.
So in a raw string, that means that you can't, that means there's no using the escape, the backslash character. I mean, the backslash character doesn't have a special meaning. I think that's what the raw string is.
That's correct.
Okay.
And what's the F string?
F string is what is the latest, it
builds up on format. So the old one was format, and this is just an easier way. So you just have everything in curly braces.
Sorry, I didn't get that.
So you can replaces.
So that os.path.sep, it's a variable and it will be replaced by its value because of the format, because of the F string. Otherwise, you will need to.
Okay. I get it.
Yeah.
Thank you.
Okay, so we get that so we can have this substituted by the actual string. Thank you. Depending on your OS. Okay. We're in labelers. But this is code reader. Let me see if we have here an example. Okay, yes. So this one, it seemed really complicated to me. It was in the case that you need to reconstruct, for what I could understand, you need to reconstruct the class name. Remember, all we're doing here is trying to get what is my class, given me a particular data file. So another way of doing that is if I have them in a data frame, like in this example, let's start with the example and we go back. This is my data frame. And what I'm saying is that my class is going to be what I have on my column A. So column A is part of my label, but it's not my full label. So I'm concatenating the prefix with my contents of column A with a suffix value. I couldn't think of an example of a data set that follows this particular format, but I'm thinking that there has to be a data set that follows this. That's what we're doing, this very specific type of
Planets data set is set up by that.
Which one?
Planets data set.
Planets data set. Okay. So you get 0 because this is my prefix, my value, A, and my suffix, 0, B, 0, C, 0, D, 1, right? All of them.
Actually,
now,
if you look at MNIST also has the labels.csv, so that is also has one more formatting which is set up with the data frame. So it's a good practice to try with that data set too.
And the part of the prefix and the suffix are used in both examples of the planet and the MNIST data?
I think even the MNIST has it set up like that, because your column name will usually just have the file name, and that's not the whole path. So you would need a column reader to kind of append your whole path in through there. So
got it. So the prefix will be the path, and that's what makes it useful.
Right.
Okay, that makes sense. So then you have this part. So this is just an example that allows us to understand, okay, what am I doing? Well, I'm taking the prefix, the suffix, and the particular column that I'm telling you. Based on that, I'm gonna construct my labels, right? So now we'll go back to the code that it's doing. Again, it's just the class. This is how, I didn't see anything really on it. Seems. Okay.
Yeah, the only thing interesting in that is the iter-tuples function, which is actually a pandas thing, and neither a FastAI nor a Python thing, but a pandas thing. So it,
which one?
The df dot iter-tuples is actually a pandas function, and neither a Python nor a FastAI function. So it gives you the tuples. Iterates through the tuples. Yeah, that one.
Another interesting thing is like just the store actor. I don't know, the fast call store actor. Instead of writing self dots, this is equal to self dots. Labeled in, can just use store actor to like put everything in self.
Yeah, but store actor, just so you, if you can
scroll up, we saw it.
Pull up question mark store actor.
Oh, sure. I think we saw it earlier, but let me go.
Yeah. Get attribute is actually a Python function. It just gets the attribute. It's built into Python, but store attribute is not. It's actually a FastAI defined thing, because he provides the names and then stores them. It's just a lazy way of creating the attributes.
Himself.
Yeah. So just a second, so what he does is he creates, and that's the reason I provided the inspect module as a reference. You go to the inspect module and you say that you'll see that the current frame fback flocals basically gives you the local namespace, and in the local namespace, that is in the namespace of the class that you have, I believe, he creates the attributes which are provided in the name string that you pass into store attribute. So instead of, and Jeremy is a really, really good programmer. So programmers never do things which I guess very good programmers never do any more work than is absolutely necessary. So he hates typing self dot suf equals suf and stuff like that. So he just types one line, store address, self, suf, label, delim, which basically what it does is it creates self dot suf is suf and self dot label delim is label delim. That's essentially what is done by store address, self, suf, comma, and you can just give it a string of your attribute names and it will create them in the current namespace for you. So that's essentially what store address does.
Very interesting.
It's again one of these convenience functions that Jeremy uses all over the place to create.
And that's the part that he said that some people may struggle a little bit, but yeah.
And I didn't know about the inspect and creating the local namespace and stuff, but it's kind of interesting how he pulled that out of Python and then just using it just to create the attributes for the class by using the store attribute function.
So Srinivas, in this case, when he uses store attribute, he could have done it with self.suf equals label data, right? A label delim, right?
No, there are two attributes he is creating in a single line. So you can create 10 attributes in one line versus having 10 lines. That's the 9 lines that he says.
Are they all being initialized to none, or how are they being initialized?
You provide them in you see they're defined in init. They're coming in through there.
You're receiving them as parameter in your function, and you're storing them. So instead of doing these equal, and like you said, one might not be too aggressive, but sometimes you might receive 5 parameters and you have to do 5 times these parameters, and they're going to say, oh yeah, just the parameter value.
Yeah.
Exactly. So instead of doing this as many times as parameters you receive,
right,
he come up with, oh, that's pretty fancy.
Yeah, exactly. So he does this all over the place, and it's kind of fascinating because you can get to be, as I said, one of the benefits of going through the walkthroughs is not just learning about the library, it's also learning about how he thinks and how he makes things convenient for himself and becoming a better Python programmer, because this is a cool trick that you can just use if you're, like she was also saying, for 1 or 2, it may not be a big deal. You're defining 7 or 8 or 10 as we go through, transform data set and stuff, and this becomes extremely handy. You don't have to write self dot da 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 da. You just say, here, go make attributes.
The gradient, right? It's going back to, it's a lot cleaner, and then it becomes intuitive and easier to understand what am I really doing in this init function. When I can get clear of the 10 other lines, just tell me, oh, okay, this is what I'm doing over here.
Yeah, right. And it's all boilerplate code anyways. So, and it shortens your code so you can stare at it and debug it and or understand it much easier too.
Yeah, this is the set. Next time, let's look at another example of this part of a little bit more details. It's true you did put it in the reference to check. I didn't get into that, but yeah, I'll catch up for next week to go into the details. Yes, this is something new. I've never seen that part. I'm not an expert Python programmer either, right? But
but I don't know. My major worry with this method of programming is because it's not common. So like if you're working in teams, I don't know, would this become an issue? Like if you should write things this way, it's not like the conventional method of writing code.
Isn't it supposed to be going or aiming for literal, what he calls literal programming?
Yeah, but the conventional method is like what other people adopt, other non-FastAI. This is very convenient. This is awesome, but I don't know. I'm just thinking out. What if you should be in a team that they don't understand this method?
Not conventional. And actually, once you start digging deeper into code, it kind of becomes harder to change things, I personally think. But yeah, I think he covers this in the next or some of the future lectures. The other advantages with store attra is that let us say you do this self stuff, and then you have to go back and change the order of one of the parameters that you're trying to pass in your init. It kind of becomes painful what self you want to go change. You need to change whether a self dot batch size or self dot, let us say number of iterations or something like that. Whereas store attra automatically takes care of the order also. And like you can just directly go and just delete one of those things that you're passing to StoreAttra, and you don't have to worry about what order it's being passed.
Yeah. I know it's convenient. I mean, for people that are not FastAI folks, like other engineers, you know, you have to explain your code.
Right.
Well, it's yeah.
I guess it's the trade-off between making things easier plus like understanding code becomes harder. I think those two go in opposite directions.
Yeah.
No, but thank you. I really appreciate the part of it also takes care of the hierarchy or where exactly this value should go.
Yeah, because this is the easy one. There are other ones, like when he's defining classes, like make class, like you see some weird things that are not conventional at all, which is why sometimes people always complain that the source code is difficult to read.
Yeah,
so if you should like
difficult
adapt to that, it's very, very convenient, but I don't know.
Yeah, it's
quite
difficult
hard to explain
to debug, like you say. In debug, many times you're like, oh my God, I'm chasing so much. But that's the reason I find going through the library in detail helpful, because it really, once you get a thorough understanding of what all the stuff he does, the tricks he uses, it's a bound set of tricks. So once you know those, then it becomes easier to debug the library. That's the other reason to go through these in detail and as much detail as possible, because then once you're familiar with it, debugging it becomes a lot. Debugging any FastAI issue or any code that you write which runs on top of FastAI, but as Rekil was pointing out, it is a trade-off between readability or debuggability, and so because some of the concepts or methods he uses is kind of not what you would typically see. But once you're familiar with those in the context of FastAI library, and that's the reason we are going through this in such detail, then it will become easier for you to debug.
So in theory, at the end, you should be able to understand not all of it, but you'll be able to understand what parts are in here, like the parts that are relevant, and what is the goal of doing them. Not that you can reproduce them line by line, but understand what is the concept that they're trying to do. Why do I get class? What am I doing there? So at the end, not right now.
Yeah. And he goes, by the way, we can defer the details of some, but some of it's until the very end, because the last two lectures, 9 and 10, are where he spends quite a bit of time going through a lot of these kinds of helper functions. But that's not being Jemmy, he wants to start at the top and go through, but it's still important to dig into these as and when relevant, because then in the context of the current discussion, we understand store attribute much better than if we were to just look at it somewhere else independently as a function by itself. So that's why it's helpful right now to discuss.
No, I think it's true. Like the part that we have seen the other example before, it gives us an idea, oh, this is how the kid's using like the splitter and this part. So you already have a little bit of blocks that are building blocks, and then you go into the details, how are those building blocks working. Sorry, we have 10 minutes. We're going to be able to get...
Can I ask a question? The last assignment of call, if you go up, the call is self.call is equal to L brackets. Go up in it.
Sorry, which one?
The assignment of a calls.
If you go up a bit, self. Like under the StoreAttra line.
Yeah, with this part?
Down below. In the initialization, the fourth initialization of columns, I think COLS, and it's the L, capital L brackets calls. So what he's trying to assign, a library, a class.
L is the list. Capital L is the list. That's that.
Oh, sorry, this part. Yeah, this is the object. This is the object.
Specialized L. Specialized list, and he'll spend quite a bit of time. You can go look at the code in the FastAI core for L, but he'll spend quite some time in one of the upcoming lectures going through the various reasons why L is better than just using a good old Python list. Think of it as a Python list, which also gives you the number of elements in the list at the beginning, but it does a lot more than that.
Because they allow to how do you create a list was a lot more intuitive. You didn't have to worry a lot about the brackets and the operation that you could do, and also the elements that you could have, correct? The elements that you could have in them.
Yeah, you can index with another list, and you can, it treats the non-objects differently, blah, blah, blah. There's a lot to it, and he spends quite a bit of one of the future lectures.
So we want to go, it was in Fastcore, and we go to the foundation. This is how I find things, but and I believe we just have to go here. So this is how what he defines, right? It behaves like a list of items, but also can index the list of max. So all the properties that he does. Yeah, but yeah, basically he implemented a collection to have the properties that he wanted.
Right. And we'll spend some time in a future lecture discussing it. So right now, think of it as a list. Yeah.
Okay. Thank you.
In here, we just have two classes, category map and categorize, which is going to be the actual transform. So this is what we are going to be using when we're creating our pipeline. Last time, we used categorize. And the categorize is going to be using our category map. Okay, so let's go back to category map. Okay, so this one is just receiving, let's say, receive all the type of, for each object, receive what is the class. So imagine that for the pets, we just receive a list or an array that contains all the possible classes for each file. So let's say this is a dog, this is a cat, this is a dog, this is a cat. So it's not unique, right? You have the class of each one of the objects. And then what it does with that, it's going to construct a sorted set of it. So we can see it here. Imagine that what we received, these were my classes 4, 3, 2, 4. And then what it's going to do is it's going to create that my classes are going to be now 2, 3, 4, right? This is, imagine that these are names, not, because they're not indexed, they're actual values. And then it doesn't only create the set, it actually creates then the mapping, because then what we're actually going to be working is going to be these indexes that if we have, in this case, 3 classes, my index are going to be 0, 1, and 2. And each one of my index gets mapped to the particular value that it was. And it makes it unique because it makes it sorted. So basically that's all it does. Oh, sorry, and it also gives you the way of getting it back. So you have a way of getting from the class name, in this case, the 2, what is the correspondent index, the 0, or from the 0, you can get, okay, the class name is 2. So this is object to index or index to objects is what you have.
Yeah, a couple of things, if I can point out. One, again, as I was saying, you learn a lot by just observing or reading through Jeremy code. If you go up a little bit in the notebook, sorry. Yeah, just hold at the category map. The thing that you would also, he flags it, but it's a trick that I hadn't seen anywhere else and was able to use it in a couple of other places, is the fact that if you see, he comments on it, that O equals O is the generalized definition of anything that is a non-nan in pandas. So that's a very cool thing that I learned, because I didn't know how you could simply grab anything that is non-nan in pandas by just using if O equals O for pandas item. So basically that says if the value is the same as the object, then that's a non-nan object in pandas. The second thing I wanted to point out, because it took me a while to dig this up, and this is an example of where, it is hard to debug or understand Jeremy's code, and that's why it's valuable to go through this, is took me a while to realize where does the val to IDX come from? And because just searching for val to IDX doesn't really give you anything. And then you realize, if you go through this code, that self.items is actually an L, and L has a val to IDX method, which creates the reverse dictionary. And that's what he uses there as self.items.val to IDX. And if you look up in the code, items is an L. So self.items is an L, and L has a val to IDX method.
The L, you can print, I mean, you can use just the L, or the L to items is true, it's just the actual elements. And then object to index is going to be, the object is 2, the index is 0, object is 3, the index is 2, or you can get it just this other way. But
right. So I'm just pointing out that, there are things even in a few lines of code that if you chase down or follow it, then you end up learning quite a bit about the library, but also about many more things than just the library.
I'm sorry, what is the part where we said that it was sorted? Because we make sure that it's sorted. I'm trying to look for the line of code. Oh, yeah, you just said here whether you want it sorted or not.
Yeah.
Usually if you say nothing, it's sorted, because I always saw it sorted, because if you said nothing, it's going to be sorted. So you get a list of categories, you create a list, and then you make sure that it's going to be unique.
And you also add or don't add NA by
if add NA, that's basically
right.
tabular when you end up using, and the important thing is that that's always added at the 0th position.
Correct.
You always put it right up front. And that's the other cool thing about list. In a normal list, you wouldn't be able to add something like that at the front. That's what capital L is basically list on steroids.
Yeah.
And
yeah, side note, actually, I was looking at this particular part, and just made me realize that sometimes for unbalanced data sets, you have to add weights based on the labels, right? And realize that one could actually extend the L to actually do that part of adding weights based on the number of the number of labels of a given class. I don't know whether I make sense or not.
So you want to know the proportion of of each class? I mean, I'm seeing that you're trying to do something either stratification or balance. But
yeah, because we need to actually add weighted loss function, right? Weighted cross entropy. We may need to actually pass weights based on your class distribution, right?
So your question is where to pass in the weights?
Yeah, how to actually whether can we actually extend L?
You don't have to do that. So you're basically you're passing in weights. A couple of ways to do this, for example, in your loss function, cross entropy loss flat takes in a parameter. Basically, cross entropy loss flat uses cross entropy loss from PyTorch. And cross entropy loss from PyTorch basically has a weights parameter. So if you find your distribution for the different classes, you can just pass in a list, a normal list, a Python list with the different weights that you want into that. That's one way of doing that. There is something called Jeremy looks into data loaders. There is a weighted data loader. So weighted data loader also kind of does the same thing. You pass in the weights and it'll sample from a batch based on that proportion.
So what you're suggesting is calculate the weight, just as a normal list, calculate the weights from that list and, pass it as part of the loss function.
Right. You calculate your proportions, and then it's just as simple as just passing weight is equal to your weights list. That's all.
Okay.
And that's to be used on your loss calculation, correct? You want to penalize.
Yeah, that's what I said. So you can do it there, or you can do it like what I said, when you're creating your data loader. So basically what is going to happen is when you randomly sample, if your proportions are imbalanced, you're going to sample in that imbalanced proportion, right? But if you tell specifically the data loader, that actually goes back to, again, PyTorch.
That was a little bit, we saw that with the train and split, but there are two separate things, right? One is to make sure that you are sampling proportionally. Another thing is that your function or the metric that you're using are going to penalize based, having a balanced accuracy versus accuracy metrics.
In essence, you're doing the same thing, right? You either balance out your loss, which basically is saying if you have 100 dogs and 10 cats, then balance that out. Or when I'm sampling itself, that is the number of images that I'm taking in one batch, I'm basically going to do some strategy where I'm going to say, even though I had 100 dogs and 10 cats, I'm going to balance them out and
5 and 5.
sample from 100 cats and 100 dogs.
So one or the other.
It's the same thing. Yeah.
Yeah. Okay, gotcha. That's gonna be when we look at how we're constructing our batches and all that.
Right, right.
Okay, that's great. Yeah, haven't looked at that part. Well, that's all we did here in categorize, and then this function is gonna.
One more thing. Sorry,
go for it.
for that. But the other thing to notice, and again, as I said, I mean it's a detail, but if you're learning your Python, then these are all things that will help you learn Python and use it better. Is you see that in self.o2i, if he is adding NA, just like Rekal said, L helps you add it at the beginning, but also he uses a default date. And the reason is then you can stick it, the int, and int's default value is 0. So a default date with int makes the NA addition easy because the default date creates dictionary of ints and its default value is 0, and self.items val to IDX generates all the rest of the
I think we're gonna see it here in this one, right? We have the same map for the same 2, 3, 4, but we added the NA, and we see correctly that the mapping of the NA is gonna be to the index 0. Because
and that's because he uses a default date int. A default date basically says use the default value for the values as whatever class I give you, which is int, and the default value for int is 0. So that's why you get the 0th index, which is actually NA, to have its thing be 0, and then the rest of the indices and values are provided by self.items that val to IDX. You don't need that when you just use the self.items that val to IDX, and therefore you don't need a default date, and it just uses a regular old date. So these kinds of things, again, are details, but they help you learn what a default date is and why providing an int and what it does in a very controlled kind of environment. So you learn that that's what happens.
Somebody else had a question or a comment? Yeah, so in here we saw that example of how we did that mapping, and then the example when we add the NA. The other thing that we're doing is when they're ordered, in case it's something ordinal, like in this case, I'm assuming that this means high, medium, low, and you want to keep them in that order, then the mapping to the indexes is going to be in that order, high, medium, low, in that, because that's how you get your categories in this one in here. What else?
I do have a question. So I haven't attended the previous walkthroughs. Is this notebook something that he's provided?
Yeah. So if you go back to the code, let me see, where am I? You go back here, just the GitHub of FastAI, and then you go one back. You go here to the GitHub of FastAI 2, and then you go to Notebooks MBS. It's not in order though. So in the first walkthrough, the only notebook that we were looking at, because this is how he chose to do that, is notebook number 10. So number 10 is the notebook that we were looking at the first time. And then right now we only are working on notebook number 5. And for that second part, we're gonna be working on the notebook number 3.
Yeah, if you look at my slides that I think Anant or somebody linked to the top of the Slack group, then you can know which notebooks are being referred to.
For example, in here, this is the first link that he created. And yes, you're going to watch the video and the video is not going to match. In this one, I believe in the first one, it was number 8 on the video, but the name matches. It was tutorial pets. And then Trinab made us a slide that it says number 10. So if he keeps giving us notes, then we can just follow his PDF to know where the notebooks are. But if not, we can just figure out by the names. But in here also it's 10, and in here we switch to data transform. Actually, this it's a different name. So it's true, we need to look at it a little bit into details, because in the original video, it was a different number, a different name, because it has modified. I believe that was B3 and now we're in B4. But yeah, so all the code is available there, and the videos from Jeremy. Look at the content of the notebooks and follow up where there.
I have a little question about like that.
Yeah.
There is another where there was a FastAI dev, and I guess that when they released it, like the version 2, they put it finally on the one we are watching now. But I am not so sure if that is the relation between those two repositories, because the other one, FastAI Dev, does have also Swift.
Oh.
Yes, if you.
That's a good question. So you're saying that there was just the dev version. Are we still using the dev version?
No,
yes.
The current code refers to the one that that she's using right now, which is the current FastAI 2. He refers to the dev in the lectures because that's what was being used when they were developing it. But as she explained, also significant development happened as the videos were getting recorded and subsequent to the walkthrough videos getting recorded. So I think the current set of notebooks is the reference one we should be using, and any deltas to the old one we'll explain or kind of point out as we go along, because this is the current one that she's pointing to.
Also, I don't know if it's something that I've encountered or if something that is consistent. You cannot just pip install some of them. For this notebook number 5, it didn't matter, but for some of them, past core, you needed to update from the GitHub and make it run. I think for number 10, you needed to do this to make sure that you have the latest version of fast core instead of getting the pip install version, the PyPy version.
Yeah, if you have installed, and I think Joseph went through this when he went through the first lesson in some detail, but if you've installed, and I believe if you follow Joseph's install instructions from that first lesson discussion, if you've installed it for following him, or if you followed FastAI's version 4 part 1, then you could just use the same environment and pulling these notebooks and continue to use them.
I think you can use pip install FastAI too. I use that.
Yeah.
For number 5, I did. For some reason, for number 10, well, it's reconnected. But for number 10, I actually had to install. Oh no, I guess it. No, you're right. It did work at the end.
Dev basically is just the bleeding edge version of it. That's the only difference as far as I know. So you can, if you want to use the bleeding edge version, you use the dev. Else you just use the stable version from pip. The one you shared, Dialog, that is from V3. There's a big nomenclature problem here. Though it says V3, that is version 3 of the course, but it still uses FastAI version 1. That's why you're seeing Swift in that. What is happening now is FastAI version 2, course V4. So there's a big number.
Okay, thanks.
Yeah, sorry, just with category, the last thing is strict. It just means drop any, I guess, that you don't see. I don't recall this part. Anyway, we just want to go to the categorize transform. Remember, in transform, what you care is your setup encodes and decodes. So what this one is in the setup, it creates these mappings and it creates what is my unique list of classes and creates the mapping. So once I have my unique list of classes and my mapping, then encoding is trivial, just to tensor category and category. I just want to mention that I was looking what is tensor category. It just passes directly to tensor base, so it doesn't actually do anything. It's a tensor base, and the real work was going to be on tensor base. So when you see tensor category, it's still just this tensor multi-category. Again, it doesn't add anything. It just directly this part, unless there was something that I'm missing there. But
no, the only two things to highlight though on categorize is the fact that the setup does two things. One, you can see, just to become familiar, you can see that store attra, again, he uses that. And in this case, he has used two things, add NA and sort. So you can see the usage of store attra for sort and for add NA again, point one. Point two is not only does it generate automatically the vocab, it also creates the reverse dictionary, the O to I. And secondly, if you can pass it and vocab, if you don't, then it creates an vocab by itself using the category.
With the category map. Sorry, and something that I consider interesting is that it also sets the loss function, which is like, why would you do that? And I was like, oh, it's true, because if you are defining categorize as your label, that means that it should be used in this type. And that's why in theory is this part that FastAI is smart. You don't need to tell it which particular loss function you should use, because you are defining what is the class of your label, right? My labels are categories. Okay, then I'm gonna use cross-entity flat. And also what we mentioned, like the order in the pipeline, unless you modify it on top of it, this is when it should be. It's usually, it's a low order, which means it gets executed fast, because it's what we do usually just with labels. We just categorize them. We don't do much.
Yep.
But it's the first time that I saw a function where we actually assign the loss function. Sorry, when I saw a transform that assigns what is my loss function.
Yeah, no, that's a very important point, because I think this is again one of these where it's hard, or sometimes you can be totally lost as to how the loss function got to be for a particular usage, how it got to be what it is, or how the default value got set. And as you're highlighting here correctly, it gets set in the transform itself, so that when you use that transform, then it automatically sets the loss function, which is not typical, and that can lead you astray. Sorry, there was some question or comment.
Yeah, sorry, I just want to mention, like, yeah, in this case, like, it magically it knows what is my loss for my multi-category. Maybe I don't remember. Oh, I don't need to, because in here they already said it. So I just need to tell it that my label is going to be a multi-category. Oh, okay, in that case, you can use your logistic class.
Yeah, somebody else had a question too, or comment, so go ahead.
Yeah, I was going to ask, like, what exactly that order equal to is doing there?
Which one?
By the loss function, on the loss function line, order equal to cross entropy loss flat, comma 1. What is that?
Oh, that's what I said. Loss function is defining what is the loss function when you have a categorization, right? Is the cross entropy. You're defining it such that when you're doing the training or evaluation or everything after, you don't need to specify what's going to be my loss function. You just define my data set has, my labels are categories.
Categories, yeah.
No.
But what is order though?
We covered a little bit last time. It's just in the pipeline when you're saying that you're going to apply several transforms to the data. And this is in the order that you're
Okay. So they're treating a loss function as a transform.
No.
It's the categorized transform itself that is being ordered in a pipe, as she was explaining.
One is the lost and the order is the one.
Okay,
yes.
Okay.
Order is one, and the order value of one is used in ordering the sequence of transforms that is given to a pipeline.
Okay. Now it's clear with the spaces. Okay.
Yeah. And we're going to get to that part, but yeah, I just wanted to see if it's possible to get, because we're going to use this part in a pipeline, and we're going to see, oh, look, and that's what it was, one. And then more in here, we just see the values, cat and dog. This another example is it's doing similar to what we're doing with the category map, but now it's a transform. That's what matters, right? Since in a transform, we're applying it to a data set. We have our data set, and we're going to transform. This is the transform that we are going to apply in here. In this case, we're just saying the only transform is going to be the categorize. So that's all they're doing. And then we know that it's going to be those two classes. So this is my data, apply my transform, it gets my vocabulary. My vocabulary has two types of classes, cat and dog.
And again, a suggestion or input is, these the way he codes and the little coding and stuff, but it also would also be very helpful if you, for example, provide some and code a cell and try to provide it some vocab, some data, and see whether you understand how the transform works. That's really how you get to understand, what it does and doesn't do, and what it encodes does and what it decode does, and so on and so forth. So it's really good to play with the transform by writing a bunch of tests yourself with data that you create yourself in order to really understand.
That's a good point. Like adding beyond reviewing these notebooks, it was good. Yeah, that's a very good point. Create new ones just to see. And there's a big difference into saying this makes sense, it's intuitive, I can understand it, and then trying to write something for something else. I see your point. That's valid. Let's do that for next time. Let me see if I can add some random example just to see how other things could look. I just want to mention multi-categorize. Similar, we specify what loss function should you use when you have multi-class. You should use this one. Same order though, because again, all we're doing with the label is categorizing them. Another thing that is relevant in here, well, we said that the tensor don't have much. I saw also that we're doing some hot encode. Oh, we can see here how it works, but basically it's how you expect it, that now you have, each class can have, each item can have multiple classes. So each item will contain a list of all the possible classes it belongs to.
Quick point that I wanted to mention out there, the one hot that they use there is not the technical one hot. In the technical one hot, you just have like one bit set to one, but here you can have multiple bits set to one. So it's more like a multi-hot. Yeah, and notice how he didn't use hot encode on the classification, right? Because you can hot encode the classification. You don't have to only hot encode multi. But in this one, because he wants to exactly put like the 3 bits of the 3 classes it belongs to, he wants to turn them on, and the other 17, it doesn't belong to, turn them to 0. Right. But it's true, I did notice that, and it was cognitive dissonance. Why didn't we have one hot encode for classification? Why only for multi-classification? But I didn't get to that part in the video.
Quick question, what is that order refers to? There was an order initialization, order equals 2.
Let me get to the example. Maybe that will help.
Okay.
No, I just want to, in the example, all we're doing here is downloading the data. Notice how we're using our get image files and not our image getter. Again, you can use your image getter. A splitter, we remember grandparent splitter was getting what is the, how should I split my data set should be on not my parent folder, my grandfather folder tells me whether I'm trained or test. As we can see here, this is the image, this is my parent, this is my grandparent, I'm trained, in this case I'm valid. So this is how I'm going to split my data sets. All the images that are in here are trained, all the images that are in here are valid. So far we read the images, we applied the splitter. In here is the first list of transforms that is using. Notice how this is the transform. All of these ones are this is the pipeline that we apply, and this is what we're using for the transform. We're getting the label. For example, notice that this also is a tuple. We have 2 lists, which means we're going to apply the same object. We have as input a path object, and then it's going to go to the transformation to create both our X and our Y. When we want to consider our X, we're going to take our path object and we're going to open the image and we're going to convert it to tensor. And then we're going to take the same object, and to get our Y, we're going to get the label. Are you a 3 or a 7? In this case, remember just the parent folder. And then we're going to categorize the 3 and the 7. Such that we can put it in tensor. So instead of having 3 and 7, we're going to have now the indexes 0 and 1. So as the output, we're going to have our tensors for the images, and we're going to have our tensors for the categories where we only have 0.0 or 1.0. And then we have the train. So notice how this is the order that we were saying is order 1. You can have negative order. So if we go back to parent label, parent label was not a transform, it was actually just a function, I believe.
Yes, but therein lies another detail that we learn much more about. But
transform.
But here's an important point, which is whenever you give a list of what you're giving here is the list of lists.
Yeah, this is one.
EFMS, right? And the two lists, each of them are pipeline. And whenever you give, you can give functions as input to pipelines too. And what the pipeline does is it takes each function or transform provided to it, converts it to a FastAI transform, and then runs it on the object that you provided. So there is an automatic conversion of every input included in a pipeline to a FastAI transform before it is run. So even though parent label is not
or even here, this one open image, right? It's not a transform.
Right.
It's a
function. It's not a transform, but when it's provided to a pipeline, it gets converted to a transform. I mean, essentially, as I've said before, this simplest way to think about a transform, it does a lot more, but besides doing the setup, it runs the encode when you call, and when you don't, when you just provide it a function, then what a transform does is it just calls that function. So in effect, when you provide a function as an input to a pipeline, it basically ends up calling that function. And that happens because internally in the pipeline, and we'll see that when we go through pipeline code, it converts each input given to it into a FastAI transform. And a FastAI transform in turn calls a function when a function is provided to it as input.
Yeah, so that's what happened. That was interesting. Thank you. I just noticed that parent label, we made a point that we didn't need to have parameters, so we were not going to do anything. Actually returns a value. And this one, we specifically said it was a transform. So we saw how it was the order. So with respect to the order, that just means that you could assign order in the function that you already have. As we saw in this one, it was 1. That means that I don't need to specify. If I put it in here and I put it in a different order, it will fix it. What number will it put for order for functions that were not explicitly defined as transform?
It's a 0. Default transform is 0. So it's a 0. That's why categorize 1 will always run after any function. So if you, for example, like you rightly said, if you flip categorize, call, and parent label, you wouldn't see any. If you flip that in that call, it wouldn't result in any difference because the parent label would get a default 0 and categorize is 1. So it will run after parent label anyway.
Oh, but in here now, because in this case, we have the functions, so they both get created at 0, in which case it does matter in which order I type them down.
That is correct. That's absolutely correct. Yes.
I find that to be a design issue. Yeah, I hear you. Because
but typically, again, keep in mind that these are examples that he uses while building up the course and explaining, but typically you will provide a bunch of transforms as input, which are all ordered and have the order. So you won't run into this kind of a problem anyway.
You're absolutely right. You don't want to be having this part, right? You want your pipelines to having them transforms, and the transform to be modular such that they have, again, this repeatable behavior that you can then just reuse every time that you have some category text. So you're right. So in this case, yes, you have more than 10 times of 10 different ways of creating it. You can leave it at this, but in that, careful, because the order matters, because we didn't convert it in a transform, so everybody's a 0. In here, this one is a transform, it has order 1, because that's what we put, so we can put it in here, this is what gets 0, so in reality, it's gonna get first extracted the label, and then the label will gonna get categorized. But basically, this is where, I just want to mention that this is how you get the, to actually execute the transform in this pipeline. And we said we created one pipeline for the images, for our X's, one pipeline or list of transforms, sorry, a list of transforms for our Y, which is this one.
And you know, for just another point of interest for those attending also the hands-on machine learning course, it's, you know, the concept of pipelines is broadly borrowed from scikit-learn, as you can see from that course that also uses a bunch of transforms and creates pipelines and stuff. So conceptually, it's the same. The details are obviously quite different.
Yeah, sorry, we don't have much time because the other class is going to start, but if we need to, we can start with just multi-categorize next time if there's something that we missed in here.
Yeah, no, I think it would be good to restart with multi-categorize. Yeah, thanks for taking us through the details excellently, and I think it will be good to start with multi-categorize next time.
Yeah, let's start with that. I'll add some more notes to this notebook before sharing it, just to mention like this is the points we made. Because a lot of good points were added during the presentation. So just to have it, I'll wait for the video to be posted, then listen to all the comments from Srinivas and make notes on the notebooks, and then I'll share them. And
thank you very much for leading this class. Great.
Sure, no problem. Thank you very much.